Let's take a look at another example here in which we are asked to find all solutions for the triangle. Now, if there is no solution, we can write none. There might be no solutions, or again, maybe one possible triangle, or maybe two. Round your sides to the nearest tenth and angles to the nearest degree, so the nearest whole degree. So I'm going to start by drawing this triangle and labeling the parts that I know. So here's angle A, angle B, and angle C. Angle A is 25 degrees. Side length A, that's opposite angle A, is 6. Side length B, that's opposite angle B, is 10. You can see I didn't really draw it to scale, but that doesn't matter. I just want to know the relative relationship of where they are. So what I'm going to do is I'm going to set up the law of sines. So I'm going to use the side I know over sine 25 equals the other side I know over sine B. And now I'm going to solve for angle B by multiplying both sides by sine 25, and by cross multiplying here, and I get 6 times sine B equals 10 times sine 25. And my next step is to divide both sides by 6 to get rid of that 6. So basically, that's gone, and I get the following. And then I do the inverse sine of both sides to solve for angle B. So B is the inverse sine of this big fraction right there. 10 times sine 25 degrees over 6. Then I can use my calculator. You'll notice I already have that typed in. Inverse sine of 10 times sine 25 degrees divided by 6. And my calculator tells me, and again, I'm going to go to the nearest whole degree here, so that's about 45 degrees. But again, there might be another answer. My calculator only gives me the quadrant 1 answer. Inverse sine is also positive in quadrant 2, so I need to put that reference angle in quadrant 2 by doing 180 minus 45. That means my other possible angle is 135 degrees. Now, if you'll look at this triangle, if angle B were 135, would these two add up to more than 180? Let's see, that would be a total of 160. So no. That means that it is possible that angle B is either 45 degrees or it's 135 degrees, which means this triangle actually has two possibilities, and I need to find both of them. So at this point, I'm going to basically do a sketch of the two different triangles I could be looking at. So here's a sketch of triangle ABC with these three given measurements, 25 degrees, 10, and 6. But then angle B could be 45 degrees. So that's a 45 degree angle right there. That's one possibility. The other possibility is that this angle, angle B, is actually 135 degrees. And that triangle would look something like this, where this is still 25 degrees, this is still 10 units, this is still 6 units. That's A, that's C, that's B. But now angle B right here is 135 degrees. So here are the two different triangles that I could have, and you'll notice both of them have those same three given measurements that I started with. So to finish this problem, I actually now need to solve each triangle separately. So in this triangle, angle B was 45 degrees. That's the first missing part. And now I need to find the other missing parts. I need to find this angle and this side length. Well, angle C is pretty straightforward because all three angles have to add up to 180. So I subtract the two angles that I know from this triangle. So 180 minus 45 minus 25 would give me 110 degrees for angle C. So angle C right here is 110. Now I still need to find this side length right here, side length C. And the way I find that is by using the law of sines. I do 6 over sine of 25. And then I do side length c over sine of 110 degrees. I need to multiply both sides by sine of 110 to get that. 6 times the sine of 110 degrees over the sine of 25 degrees is equal to side length c. You can type that into your calculator and you will get that side length c is 13.3 units to the nearest tenth. So that's one solution there, is that this triangle has those 3 given parts and then these 3 remaining parts for angle B, angle C, and side length C. So those 3 answers go together as one possible triangle. But again, there's another possible triangle in which angle B is actually 135 degrees. And now for this triangle, I find the same remaining, or those same missing parts. I find angle C and side length C as well. And the way you find them is the same. You subtract from the angles you know from 180. So 180 minus 135 minus 25 would mean that that angle C right there is 20 degrees for this triangle. So that's 20 degrees. And then I can find side length C here the same way I did here, using the law of sines. Using side length A is 6 over the sine of angle A is 25 equals side length C over the sine of angle C, and in this triangle that's 20 degrees. I multiply both sides by sine 20 to get 6 times the sine of 20 degrees over the sine of 25 degrees equals side length C. Type that into your calculator, round to the nearest tenth, and you should get 4.9 as that missing side length. So this is the second possible triangle here, in which angle B is 135 degrees, and it has those same 3 given sides that we started with. How about you try one? Give this one a try. If no solution exists, write none or find all possible solutions. So you can pause this video, give it a try, and then press play when you're ready to check your answer. Welcome back. How'd it go? Did you get no possible solutions? Because that's it. Man, that one was way quicker than the last one. Because when you type this in, you get there are no angles that work. So that side wasn't even long enough to reach this one in reality. Okay, let's try another one. That was fun. Here, try this one. Again, give it a try on your own. Press pause, and then press play when you're ready to see the answer. Hey, welcome back. Let's take a look at what you got. Did you get this one solution? So you'll notice I did the law of sines. I thought there might be 2, but then I checked that 163 degrees with the angle I already had, and it was too much. So that told me there was only this one solution, 17 degrees, and I found then the remaining parts. On a test or quiz, I would expect you to write down that to show me that you did consider the second possibility and then ruled it out. So I think that's it. Go ahead, give the homework a try, and email me with any questions you have.